Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're going to talk about how to write functions to describe real-world scenarios based on word problems. So we're going to be given a problem, we're going to have to come up with our own variables, write a function that describes the scenario using those variables, and then maybe use the function to figure out some missing values. Before we get there though, let's do a quick review from last lesson. We have a table here, and we are being asked to come up with a function that describes the points in the table. So take a few minutes to do that. Maybe you need to look through your notes from last lesson to help you with it, but then come back and join us for a discussion. Okay, so the first thing to remember that might make this a little easier is that we can treat this g of x, right? We can treat that as a y. Just so that we remember that all those points in the bottom row are y values or output values. And it may make it a little easier when we're substituting in for our slope formula and whatnot. We also know that we're going to start with point slope form when we're building our own equation or function. And we can have a y here for now, right? At the end, we can replace that y with the g of x, just because sometimes it's easier to maneuver an equation with a y rather than a g of x. Both things follow inverse operations, right? We can treat g of x just like a y and move it from one side to the other, but we're just more comfortable with y at this point, so it's fine to use the y representation until the very end. You can choose any point you want for your x1, your y1. I'll choose the first one, negative 2, 6. So I have y minus 6 is equal to some slope times the quantity x minus negative 2. To find my slope, we know that we'll use the slope formula. Change in y over change in x is equal to y2 minus y1 all over x2 minus x1, which means I need to pick another point from the table. Let's go with 4, 9. So that is going to give me 9 minus 6 all over the quantity 4 minus negative 2, which gives me 3 over the quantity 4 plus 2, which gives me 3 over 6, which is equal to 1/2 or 0.5. Either way is acceptable because the decimal is exact. I'll use the fraction this time. So now we're going to put the equation slope-intercept form before we substitute that y out and replace it with the g of x. So I'm going to distribute. Well, you know what? Before I distribute, let's simplify. So I get y minus 6 is equal to 1/2 times the quantity x plus 2. Now it's a little bit easier to distribute. I'm going to come up here. I get y minus 6 is equal to 1/2 x plus 1. 2 times 1/2 is 1. I'm going to add 6 to both sides. And I get y is equal to 1/2 x plus 7. Now, it does say to write a function, so we're going to replace our y with the g of x, because that was the function notation given to us before, and I get g of x is equal to 1/2 x plus 7. There's my function notation. All right, just a little review, and I think we are now ready to move on to some word problems. Okay, let's take a look at number 1. So it says a cup of coffee is initially brewed to 120 degrees Fahrenheit. Each minute that passes, the coffee's temperature decreases by 4 degrees Fahrenheit. Write a function t of m that represents the coffee's temperature after it has been brewed. Let t represent the temperature of the coffee and m represent the number of minutes that have passed since it was brewed. So it already gives us the variables we need to use, and it tells us what those variables represent. So again, sometimes it helps to write out an equation in words before we then go ahead and substitute in numbers and variables. So we can start off with the coffee's current temperature. Now, this is going to be equal to, well, the initial temperature right after it has been brewed, plus the change in temperature, right? The coffee is changing for every minute that passes. The coffee's temperature is changing every minute that passes since it came out of the pot or after it stopped being brewed. So let's see if we can start to fill in some numbers and variables for some of these words. Well, the coffee's current temperature, we don't necessarily know what that means, right? Because that is dependent on how many minutes have passed. So that is going to be our T of M. That depends, the temperature depends on how many minutes have passed since it has been brewed. We do know what the initial temperature is. It told us that was 120 degrees Fahrenheit. And the change in temperature, well, it says the coffee's temperature decreases by 4 degrees Fahrenheit per minute. So I know we have adding up here, but the change ends up being negative. So it's going to end up being minus 4 times m. And if you had put minus up here instead, that's fine. As long as you understand that what you're doing with the initial temperature, you're taking away, you're decreasing the initial temperature, because after it's been brewed, it is cooling off. It's not getting any hotter. Okay, so let's go and see how we can use this function to answer some of the questions down below. I'll rewrite the function here for us. We had T of M is equal to 120 minus 4m. So it says, how hot is the coffee 15 minutes after it has been brewed? Well, the 15 minutes, we need to know where to substitute that in. Is that a m value or is that a t value? Well, it's minutes, so it's going to be an m value. So I'm going to substitute in for m. So T of 15, what this represents is the temperature after 15 minutes will be equal to 120 minus 4 times 15. That gives me T of 15 is equal to 120 minus 60. And I get T of 15 is equal to 60. And to be fair, we should include units with our final answer. We need to know how to explain what this means, right? This is letters and numbers and symbols. Well, we should be able to explain or write down in a complete sentence what I just boxed, what that represents. So think about it for 30 seconds. See if you could write a sentence that represents what I have in that box, or either be able to say it verbally. So we would read this as, the temperature after 15 minutes have passed is equal to 60 degrees Fahrenheit. Okay, on to part C. It says, if the coffee's temperature is 78 degrees Fahrenheit, how many minutes have passed since it was brewed? Well, this time they're giving us a T value. They're telling us what our output is, because they're giving us a temperature. So we're not going to replace the M with 78. They're telling us that T of M is equal to 78, and we need to figure out what M value gives us a T value of 78. So we replace the T of M with 78, and we keep the rest of the function the same. Now I'm going to solve for M. So I'm going to subtract 120 from both sides. That gives me negative 42 is equal to negative 4m. Oops. If I divide by negative 4, I get 10.5 is equal to m. And we know that this is in minutes. So same thing as for part B. Pause the video and see if you could come up with a sentence that describes what I boxed in red. Not just that it's 10.5 minutes, but what does that have to do with the problem? So what this represents is that after 10.5 minutes, that is when the coffee's temperature will be 78 degrees Fahrenheit. All right, let's move on. We'll do number 2. So it says Vivian has $200 in her checking account. She just got a job that pays her $7.50 an hour. She makes no withdrawals from her account and deposits every dollar that she earns from her job. So we need to write a function that represents the amount of money Vivian has in her account after a certain number of hours worked. We're allowed to use whatever letters we want for our variables, but we'll need to explain what each one represents. So go ahead and try to come up with what our two variables should represent. Basically, you're trying to figure out what are the two quantities that are changing in this problem. What are the quantities that are not constants? Okay, so the first quantity that's not a constant is the number of hours that she works. And let's use h for hours. So we'll say h is equal to hours Vivian works. The other quantity that's changing is the amount of money in her account. So let's say m is equal to money in Vivian's account. That's going to go up for every extra hour that she works. So we need to write a function. Our function is going to be m of h. So m of h, the money in her account, is a function of how many hours that she works. Now, we got to think of, okay, what are the amounts that make up the money in her account? Well, she has an initial amount, right? She has the $200, that's an initial amount. And she also adds money based on how many hours she works. So she adds $7.50 for every hour. So $7.50 times h, which represents the amount of money that she deposits for all the hours that she works. Money earned. Let's make that a little better. It's not too much better. Okay, let's try this one more time. There we go. Money earned from working. So there's our function. M of h is equal to 200 plus 7.50 times h. First question, how much money will Vivian have in her account after she has worked 212 hours? Well, this 212 is an h value because it stands for hours. So we have m of 212 is equal to 200 plus 7.50 times 212. And now I just need to simplify. I'm going to get m of 212 is equal to 200 plus 1,590. And then I'll add those two together to get 1,790, and that's going to be in dollars. Pause pause the video for 15 to 20 seconds and see if you could either come up with a sentence in your head or write down a sentence that describes what we just boxed in green, because we want to be able to describe our final answer in words as well as symbols. Okay, so how we would read that would be the amount of money in Vivian's account after she's worked for 212 hours is $1,790. Or you could say Vivian has $1,790 in her account after working for 212 hours. I believe there's a third part to this question. It says, how many hours did Vivian work if she has $942.50 in her account? So let's start with our original function. M of h is equal to 200 plus 7.50h. And this time they're giving us a dollar amount. So we have to think about which variable stood for money. Well, it was the m. So we're going to replace the m of h with 942.50 and solve for h, because we're trying to figure out how many hours it took her to obtain that much money in her account. You can start off by subtracting 200 from both sides. That's going to give us 742.50 is equal to 7.50h. Can divide both sides by 7.50. And that's going to give us 99 is equal to h. And we should make sure we have units here. That 99 represents hours. Final time, pause the video, see if you can come up with a sentence that describes our answer. Okay, so a couple ways we could say it. We could say after 99 hours, Vivian has $942.50 in her account. Or we could say, when Vivian has $942.50 in her account, she has worked for 99 hours. All right, so I do want to go over one more before we end this video, and that is going to be number 4. So it says it costs a movie theater $2,000 to open each night, $2,000. They then make a certain amount of money for each patron that comes to see a movie. If 300 patrons come to see a movie, then the theater profits $1,300 for the night. So we need to write a function p of x, where p represents the total profit the theater makes in a night, and x represents the number of patrons that come and see a movie. So we already have our variables, and now we can try to build our function. So to start us off, let's actually talk about what this equation or function would look like in words before we then move on to numbers and variables. So we know that we're looking for the profit that the theater makes. So profit is going to be on a side by itself. Now we need to figure out what are the things that go into profit. Well, we have the initial cost the initial cost to open the theater each night. So cost to open, cost to open theater plus the revenue, right? How much money they're making from patrons coming to see movies. Money made from people, people coming to see movies. I know it's a little long, but I wanted to make sure we understand what that means. Let's make profit a different color. So we know what profit is, right? That tells us that's our P, right? That's our P of X. We also know what the cost to open the theater is, right? We know that's $2,000. And in this case, it's going to be a negative 2,000 because it's costing the theater $2,000 to open, which means they're having to pay $2,000 out of their own pocket. That's not money that they're getting, it's money that they're having to dish out. Now we need to figure out revenue. Well, the revenue is made up from the patrons that come to see the movie. So we would take the number of people that come times the cost for a movie ticket. So we'd have plus P times the cost of a movie ticket. The problem is we don't know what the cost of a ticket is, right? That's like an extra unknown. So we can't just build our function this way, right? This way worked for the first two problems we did. We had enough info in the problem to just come up with essentially the y-intercept and the slope, right? Because we were writing these equations in slope-intercept form, or these functions in slope-intercept form. But here, they don't tell us how much each patron has to pay to come see a movie. So we're going to have to try to figure out a different way to set up this function. Because right now I have too many unknowns, right? I have the P, but I also have this other question mark. So we need to essentially figure out, is there a way for me to find out what the slope is, right? This is our y-intercept. And maybe it'll help if I rewrote this a different way. If I did P of X is equal to question mark times P minus 2,000. Right? This should look like slope-intercept form, where that's our slope, and this is our y-intercept. So if we could figure out what the slope is, we would be able to write our function. Well, let's backtrack. Let's get rid of this. Let's think about what slope represents, right? Slope is change in y over change in x is equal to y2 minus y1 all over x2 minus x1. Can I come up with 2 points here that I could substitute into that formula? Well, and remember, P of x, right? We could really think of P of x as our y values. Those are our outputs. The P would essentially be our x values or our inputs. Well, I have 1 point given. It says if 300 patrons come, the theater profits $1,300. So 1 point would be 300, comma, 1,300. They also tell us it costs a movie theater $2,000 to open each night. Well, it doesn't tell us a number of patrons that corresponds with 2,000. But if that's how much it costs for them to open, that would be the cost or the profit for 0 patrons. And we have to remember that 2,000 would be negative, right? Because if 0 patrons come, the theater would have to pay 2,000. They wouldn't make 2,000. So that would be another point. And all of a sudden, if we have 2 points, we can use the slope formula. So I'm going to get I'll do 1,300 minus negative 2,000 all over 300 minus 0. That's going to give me 3,300 over 300. That gives me 11. So my slope is 11, and essentially that means that it costs $11 for people to come and see a movie, $11 per ticket. So now we could write our function. And you could either think back to what we had before, right? We had P of X is equal to the question mark, which was our slope, times P minus 2,000. So we know what our slope is now, right? We know that's 11. So we get 11p minus 2,000. If you forgot that, right, or you weren't able to come up with that on your own, well, we could just keep going by starting with point slope form, right? Because that's how we normally build equations if we're unsure of where to start. I'll use this point right here. So I get y minus 1,300. I know my slope is 11 times the quantity x minus 300. I get y minus 1,300 is equal to 11x minus 3,300. That's if I distribute. If I add 1,300 to both sides, that gives me y is equal to 11x minus 2,000. And then we can replace our y with p of x, because we want to write this in function notation. And notice that either way, you would get the same function. Okay, that is going to wrap it up for this video. Hopefully you've learned enough to be able to approach the other problems on your own, although we will cover those in class as well. So as always, enjoy the rest of your day, and I will look forward to seeing you next time.